Cool. Hi, everyone. It's super exciting to see people from India, some familiar faces, and even some people like joining from other parts of the world. I hope everyone is coming up with creative ideas while at home and staying safe. So yeah, like welcome and thank you for joining. I'm Akshay Chordiya. I'm based in Berlin, Germany. I'm originally from Pune, India. I work as an Android engineer at Clio, which is a female health company. Uh, I'm also an Google developer expert for Android. And today we are going to talk about something which many people are excited about, that is Kotlin Flow. The goal of this talk is to tell you why Kotlin Flow was designed, some of the basics, and show what makes Kotlin Flow special, and show how you can migrate to Flow if you want to, and how you can architect Flow, and like most important thing like testing. So this is a bit advanced topic, and I'm super glad that Philip covered the basics of Kotlin so that you can dive into this. Um, okay, so before we move on to Kotlin Flow, let's rewind a little bit and look at what Kotlin gave us, that is coroutines. Some of the people were asking about coroutines in the chat, so I'll just cover like briefly about it. So the coroutines, they basically simplify asynchronous programming in general, and especially on Android. So let's take an example of a synchronous function called as show user, which internally like uses the database and loads the user and then calls the render function to show it. So when this function is called, like the load user is called, it blocks the current thread and waits till the user is loaded from the database. This blocking the thread is really bad because at that moment the whole UI is frozen. That means the user is super unhappy and like sees your app like lagging and freezing. And then once the data is loaded, the render function is called, and then the data is shown on the UI. So there are like multiple ways to tackle this. So let's look at how we can like tackle this problem using coroutines. So let's start by taking the original synchronous function over here. So first we need to mark the show user function as suspend. Of course, we will need to mark the load user function as suspend too, since we also want it to run on the background thread. So what happens is that like when you mark the suspend is a special keyword in Kotlin programming. So as soon as you mark any function as suspend, it basically runs on the background thread. But there is a problem that the render function needs to be called from a UI thread. So like I said, like when you mark the function as suspend, it runs in the background thread. But like on Android or any of the UI based like platforms, you need to touch the view from a UI thread. So you need to basically switch this to UI thread. So we can use a function called as with context, which allows you to switch the thread inside the suspending function. So here the with context is changing the thread to main thread so that the render function is called from a UI thread. And that's it. Like that's how you can just literally convert any synchronous code into asynchronous. And that's why like coroutines is so nice and easy to use. So let's look at how this internally works. So what happens is like when the show user function is called, it like shifts the thread to the background thread, since it is marked as suspend. And then it calls the load user function in the background thread. And as you can see, the main thread is still continuing to go on, while on the other thread, the database operation is going on. So without waiting, or like here, the app is not freezing because you're doing the heavy operation on some other thread. And then once this is finished, it will switch back to the main thread because of with context. It will switch back to the UI thread, and then the render function will be called. So you will get what you wanted to do. So basically, a suspend function can only be called from another suspend function, or from a coroutine scope. So let's look at what coroutine scope here is. A coroutine scope represents the scope of the coroutine, like so in which scope the coroutines are gonna run. So each coroutine needs the scope to run in, and when the scope is destroyed, all the running jobs inside the scope are cancelled or like stopped. The scope is generally associated to a lifecycle scope for simplicity. For instance, on Android, each activity has its own lifecycle. So that means that like whenever you can associate the coroutine to the scope of the activity, where like the activity is created, you run that coroutine, and when the activity is destroyed, it is cancelled. So let's take the same example with the coroutine scope now. For example, here, like in order to call our show user suspend function from a no, so basically the show user function is a suspend function, and the main function over here is a normal function. So in order to call suspend function from a normal function, you need something called as a coroutine scope, and that's here is the lifecycle scope. So this lifecycle scope particularly is provided by a library from Jetpack components, like I think it's lifecycle KTX library. Um, so it is provided by the Android team for us to use coroutine on activity and fragment. So this lifecycle scope is tied to the lifecycle of activity or fragment. Yes, so the same stuff. Yeah. So this provides the magic of automatically clearing or canceling all the jobs running in the specified scope when the activity is destroyed. And the launch function is used to start a coroutine. So it's kind of like how you launch a thread or something. So what will happen is when you call launch, it will execute the coroutine, which is show user function over here. This also means that the coroutines are hot in nature. This is also one of the reasons why coroutines are not like one-on-one replacement for reactive streams. So by that, now we know that like a coroutine scope is kind of a subscription management system, but associated to a life cycle. This concept is called a structured concurrency, and this is what makes Kotlin coroutines so powerful, and also helps like developers prevent leaking the subscription or the job of the task running. So let's come to the important question: why Kotlin Flow? Like, I mean, there is already Kotlin coroutine, and there's already like RxJava or so many reactive streams library. So it naturally is a good question, like why Kotlin Flow was introduced in first place. So like I said, like a lot of people started loving coroutines because of how simple it looks. Your code looks super sequential. It's super easy to use, and with the benefit of structured concurrency, it just prevents a lot of issues from happening. And that kind of led to a growing usage and a love for Kotlin coroutines. And at that moment, people expressed a lot of interest of having a pure Kotlin implementation of RxJava or like reactive streams in general, to leverage like, so RxJava is a library for reactive streams, but it's tied to Java programming language. It doesn't leverage the amazing features which like Philip talked about, which Kotlin provides. So naturally, the next question for the Kotlin team was to create a magic, like some sort of a wrapper on top of RxJava, so that they could leverage the Kotlin feature, or to build a library from scratch. So Rx Kotlin does exist, but it cannot like since it is like RxJava itself is based upon Java programming language, it cannot really leverage all the features which Kotlin provides. So it's like makes it a bit more nicer, but it's not like really amazing. So at the end, to me, it's important that any new library raises the bar compared to any existing library out there, and it's not just a replica with a slight improvement. And that's what like Kotlin Flow does, and Kotlin Flow actually raises the bar of reactive programming in general. So let's look at like what makes it so special in order to raise the bar and like make it so nice. So the first thing is like Flow provides like null safety in the stream. That means you cannot send null values in the stream. This is not something new. This was introduced in RxJava 2. RxJava 2 also has it. Second is like this is the key thing over here. Flow provides an like interoperability. between React streams. Like you can convert between RxJava 1 types or RxJava 2 types, like flowable, observable to flow and the reverse. You can also combine flow and coroutines. We will see this later during the presentation. Um, you can even use Kotlin Flow and actually like the whole Kotlin coroutines in Kotlin multi-platform. This means that you can use Flow on any of the supported platforms, like even on like JVM, JavaScript, native. Plus, you can use it in the common code or the shared code for Kotlin multi-platform projects. Fourth is like there is no special handling for back pressure. This is like a pain when you're dealing with reactive libraries, especially on Rx. With Kotlin coroutines and flow, there is literally no operator for handling back pressure. I mean, there are like some things which you can do for sure, but most of the cases are like magically handled by the suspending nature of coroutines. Plus, like if you know, like if you have used RxJava, you might have noticed that like there are like tons of operators, and it's really hard to know all of them or like to find the right one for your use case. And they're not like super simple. You need to like read a lot of documentation or articles, see those famous. And also like Kotlin Flow leverages the perk of structured concurrency, which we talked about before. So coming on to like what is Flow? So Flow is based upon the reactive stream specification. So this is a specification which is commonly designed how a reactive stream library should be. RxJava 2 follows it, Reactor project follows it, and even Kotlin Flow follows the same specification. To be honest, you can think Flow exactly as similar to a list or a collection. And similar to like a list or a collection, it has a lot of operators like map, switch map, and etc. Flow is built on top of coroutines, which is really nice. The only difference, like I said, like it's similar to a list and collection. So the only difference between list and a flow is like the flow is actually cold in nature. So we will see what this actually means as we go in the presentation. Now it's time for some basics of Flow. So essentially, there are like two components in any reactive stream library that also applies to Flow. That is like there is an emitter who emits these new values, and the other part is like a collector which receives the value. Here is an example of an emitter which returns. So here is an example of an emitter which returns flow of a string. So kind of like how you would return a list of string. This is like just flow of string. So there are also like various ways to create a flow using something called as flow builders. So they are like functions provided by Kotlin Coroutines library. They internally create the flow for us. We will come to them later, but here is the most common flow builder, which is like flow block. Okay, and then so this block of code inside the flow block, since like flow is called, like I said, will not be called until there is a subscriber or a collector observing the flow. So this will not be called. Moving on to the second part, the collector. Here we have a main function which gets the flow inside the running block using the stream function. And for people who haven't used coroutines, run blocking is a function which like is a blocking coroutine scope. That is, it blocks the current thread until everything is completed. Usually you would use this in testing, but right now it's like just a sample. That's why I've used it. So because like we need so run blocking is a scope, and since collect function is a blocking is a suspending function, we need a scope to run it in. We will see why the collect function over here is actually a suspending function. So let's look at how things are working. So what would happen is like initially the main function calls the stream function over there, which immediately returns the flow back to us. And then we call the collect function. which essentially means, oh, sorry, yeah. So so once it returns, we call the collect function, which essentially means that we are now subscribed to the emitter to receive the value. And as soon as we are subscribed, the emitter will start emitting values sequentially. So it will start with like the first emit. So emit is a function which allows you to like tell the collector of, okay, here's the first value, take it. And in this case, it will emit the first value over here. And this will go on sequentially, and the collector receives it and prints that value. And then the same happens, like so the same loop continues. We call the next collect is called, it goes to the flow back again, where it emits the next value sequentially, and then we can print it. So this goes on until there is like no value at all. And then once there is like no value, so once the emitter says that, okay, I'm done, I have no value, the collector will come out of the collect function and just end the call. Okay, now we know some of the basics of how collector and emitter and how Kotlin Flow is structured. Let's look at how it is working internally. As I mentioned before, like Flow is based upon two components, like the collector and the emitter. Essentially, they are just interfaces. The following interface over here represents the collector, which exposes the collect function, which we saw before in the previous slide. And then similarly, the emitter is also an interface, which exposes the emit function, which allows emitting the value. The key thing to note over here is both the functions are suspend, which allows the magic of interoperability between coroutines. Like we saw before, like any coroutine function, any suspending function can call a suspending function. This allows us to call any other suspending function inside the collect or emit block. This also gives the coroutines the magic of handling back pressure and gives the magic of structured concurrency, which we saw before. The funny thing is, like the whole mechanism of Flow is essentially just calling collect, so calling the emit function from collect and the collect function from emit. So these functions are all the time calling each other, and that's it. Like that's how the whole reactive stream is based upon for Flow. Just these two functions calling each other. Flow loves coroutines, also because it's built on top of coroutines. Let's take an example of a simple function which loads data from the database. Since this operation takes some amount of time, you would ideally want to perform it on a background thread. So since we know coroutines, we would mark it as suspend just to make our things easier. And the funny thing is, like since this is now suspending function, you can just literally call it from the flow block. So like I said, like the flow block is a suspending in nature. So that means you can call any other suspending function from the flow block. So for example, here inside the flow block, we can load from the database or like perform a network operation and then emit that value. This is because the flow builder function over here accepts suspending lambda. That's why like you can pass you use a suspending function, which is just super great. So now we know like some of the basics and so how Flow loves coroutines. Let's look at like what are the principles of Flow and how they make our life easier compared to other reactive streams. So with Flow, you can define or switch the thread by using the operator called as flow on, which takes a dispatcher, like the flow on operator, which takes in a dispatcher. Basically, dispatcher is basically like which thread you want to run it on. So in this case, I'm saying like run this operation on IO thread. So this operator sets the specified thread. So this operator sets the specified thread, but it sets it only upstream. So basically anything above the flow on operator will run on IO thread. And let's say we have one more, like have another operator which is after the flow on. Like let's say we have a map operator. So this map operator will not run on IO thread. So basically, like the flow on operator only affects anything above, basically the upstream, only things above the flow on operator. This concept of preventing context from leaking is called as context preservation. This is one of the principles of Kotlin flow, where the context is encapsulated and it's never allowed to go downstream. So basically, there is only one way to change the context of a flow, that is just upstream. Um, so at this point, you might be wondering like why and how this is super useful. So if you compare this to RxJava, where it's super confusing, especially for beginners to understand which thread their code is going to run on. For example, like you have the subscribe on, which allows you to set the thread as IO, but it also affects downstream and also upstream. And like so as you can see over here, like even if you call the subscribe on again as computation thread, it will still run, the next map will still run on IO thread, which is like super confusing unless like you know about RxJava in much more detail. And this causes a lot of problems for beginners and also like for debugging. Combined with another operator, like so RxJava has like two operators to switch the thread. One is like subscribe on and the other one is like observe on. This leads to like a very confusing behavior, and it's super hard to understand. And it's like a face palm moment. So the second principle of flow is exception transparency. So flow implementations never catch or handle exceptions that occur in the downstream. This is partly because of context preservation. So what happens is like if any of your code throws an error, so if you have a catch operator, like we will see that, it only catches the issues upstream. So let's look at an example to understand this principle. So let's take the previous example of a flow which tries to get the value from the database and then emit. As you can imagine, anything can happen while loading from the database, and we might throw some sort of an exception while loading from the database. And in order to handle that, you can use something called as a catch operator. So this is an operator provided by Flow to catch any kind of exceptions thrown above the catch operator. So similar to what we saw before, the context transparency, like context preservation. You can just so anything below the catch operator will not be handled. So this is, you can even actually use a classic try catch block inside your flow builder. This will behave exactly similar to the catch operator, which we saw a second ago. But but I would recommend to use the catch operator because but there can be use cases where you want to use the normal simple old try catch. During those times, just make sure to ignore the cancellation exception, because you don't want to, So because you don't want to emit an error when your flow or coroutine was canceled. So this cancellation exception is thrown by Kotlin Coroutines when the coroutine or the flow was canceled, and you don't want to treat it as an exception of your business logic. So at that time, so it's just important that you ignore this error and throw it back again. So this is exactly how the catch operator actually works internally. Or if you really want to use a classic try-catch operator, not the operator, the try-catch block, you can specifically handle the exception you expect to see. For example, in case of a database, maybe you are certain that it will throw a IO exception. In that case, like rather than using the exception class, you can use the IO exception so that you specifically handle that error and you don't catch the cancellation exception. Okay. Right. So the value emitted from the catch so the value emitted. So when there is an error in the flow builder or anything above the catch operator, it will be handled by the catch. Here in the catch you can emit a new value. Like you can give a fallback value or an error state or something, which will again be received in collect. So collect is like the terminal operator over here, and it will basically collect is a single place to handle all types of case. Either if it's a success or failure, unlike RxJava where you need to have where you have like two different functions like success and failure, where you it's not like super transparent to which doesn't make it super transparent to handle all these cases, all the cases of your business logic. Where Flow just provides you a single operator, which makes it like super transparent that you will handle all the cases of your business logic. I would recommend to toss in seal classes so you cover all the cases. For example, when it's a success, you would emit a success state, or when it's an error, there was some error, you would catch and emit a failure state. And in the collect, you can use the when, and then based upon the seal classes, you would handle, you would be forced to handle all the cases of your business logic. So now at this point, you might be confused when to use flow and when to use suspend. So this is like a rule of thumb for you all. So use suspend. So as a general rule of thumb, use suspend for one-shot operations like inserting into database or like network operations using retrofit or any other networking library. And use flow when there is a stream of data involved. For example, getting data from a database where you want to continuously listen for updates in the database. Like for example, you have a database stream and you want to update the UI as soon as the data is changed in the database. So in those cases, use flow. So one of the coolest thing which I love a lot is Flow provides an amazing API to convert any legacy callback based API to Flow, because now at this point you would be in love with Flow and you want to try it out, but you have some sort of a legacy code, which all of us do. And at this point, you would want to convert your legacy code into Flow. Flow provides an amazing API to do that. So let's say you have a function, like this is a classic legacy code, well, like not a classic legacy code, but in general, like it's a callback based API where you have something called as a document. And so what you want to do is like when each time the document is updated, you want to update your UI over here. So basically this is like a listener. So every time the document is changed or updated, it will update the UI. This is like standard callback based programming. And you would also need to remember to remove the listener, since you're adding the listener over here, at some point you would need to remember yourself to remove the change listener. For example, when the activity is destroyed or like the fragment is destroyed, something like that, you would want to remove the change listener. So let's look at how Flow provides an API to convert this callback into a flow. So Flow provides an API called as callback flow. In that, you would use the same change listener, because that's so what you would do is like you would add some sort of a mapper or a wrapper to convert your callback based code to a flow. That's why it's called as callback flow in first place. Here you can, like, whenever there is a change in the document, you can say to Flow that here I am offering a new value to you. Basically, this tells the Flow, it's kind of like emit function, but it's a bit different because it uses channel. Let's not talk about channels now. But in general, like this will tell to Flow that here is the new value, update yourself. Yeah, and then at some point you would need to remove the listener, right? Like we saw before. So Flow provides an amazing function called as await close. So this function is called when the coroutine is cancelled. So here you can safely remove your listener. Finally, with code comments, it looks something like this, which a lot of people forget to write about. Yes, so yeah, that's how you could convert your legacy code into Flow. Now, let's say you do that, but you're already using some sort of a reactive stream. a library like maybe RxJava. I'm gonna give a specific example of RxJava 2 over here. The goal here is not to tell you to go next moment and migrate your entire code base to Flow. I mean, that would be great for your own projects, but I mean, in the companies, you would not go directly and change everything to Flow. Um, like I said in the very beginning, that Flow follows the React Stream specification, and which is also followed by RxJava. And so this makes, in theory, it super easy to convert from Rx to Flow and the reverse. So there are like two ways to convert or your like Rx implementation to use Flow. Um, so first one is like you refactor your Rx implementation to use Flow, like the whole implementation, but that's like time consuming, and sometimes you just want to switch the types so that you can gradually migrate to Flow. In that case, you can use an extension function called as Flow, provided by the Kotlin Coroutines Rx2 dependency. It's part of that. So this provides an extension function to convert your RxJava to observable or flowable. It also supports maybe and singles to convert to flow. And the same can be done in the reverse way, where you already have a flow, but you wanted to use this flow with your legacy code or like with your RxJava code. You can quickly switch your flow to an observable using this extension function called as observable. This will convert your flow to an observable type. So here is a quick comparison of terminologies between Rx and coroutines, which I stole this from the clues documentation. Like, yeah, we have the documentation in a clue code base. In my defense, I created this table at clue, so I think it's fine to steal it. But use this chart as a reference when you're new to coroutines world or working on migrating from RxJava to coroutines or the reverse. So okay, like you can see that we have covered pretty much everything mentioned over there except channels. Now it's time to look at something really fun. So as we saw before, like Flow provides an amazing API for you to convert your observable into Flow. But the thing which is super cool is that internally, this function actually uses the callback flow, which we saw in the part where we were talking about converting your legacy code or a callback-based code to Flow. And this is super cool. Now to the everyone's favorite topic, which is like testing. Testing Flow or coroutine is pretty easy. Let's take a very simple example of flow of string, where it emits a string called as Bob the Builder. Super cool. And then you write a test for it. And then, like I said, you would want to use run blocking scope, coroutine scope over here, because you want our test to wait till all the coroutines are completed. That's the purpose of run blocking. It just blocks the current thread till everything is completed. So like I said, like flow, here you can see that we call the get flow. We use an operator called as take, which picks the first value from the stream, which is like in this case Bob the Builder, and then we use something called as toList. toList, so that we convert the flow to a plain old list, and then we can just assert the list. You can see that you can literally see here like how flow is super similar to a list, except that it's a bit cold. But yeah, like you can even use, so I have created this extension function, which I stole from I stole this from our clue code base. So this is a quick extension function. So with this, your code would look a bit more cleaner. Like you can call get flow and call assert items, where you can like assert. So you don't need, so basically internally it does the same thing. It calls the take operator, and then it takes number of values that you wanted and converts it into a list so that you can assert it easily. So this is just like a syntactic sugaring in a way. So to conclude, here's a quick summary of what you learned today. So we revisited coroutines. We saw why Kotlin Flow came into the picture and what makes it so special. We saw basics of flow, that is the emitter and the collector, and how they work internally, and how flow is cold. That means that it doesn't emit any value until there is a collector for to receive those value. We also saw principles of flow, that is context preservation and exception transparency, and how they make our lives easy. Um, then we saw how to convert RxJava or your legacy code to flow or vice versa. We also saw how would you test your flows, and we also saw some pro tips along the way. Kotlin Flow raises the bar and makes reactive programming super easy, and allows us to use great Kotlin features, which like also like Philip mentioned, and there are like tons of amazing features which Kotlin provides. And that said, like it's still work in progress. Like the Kotlin Flow library is still work in progress, and there are like lots of exciting things, more operators and like more features, which are which are still in progress, and they will be coming soon. Yeah, that's it. Thank you.
Question is by Rohan Singh. He asks, what does back pressure mean?
Okay. So back pressure in simple words means that so like we saw that there are like two parts to any reactive stream library, like the collector and the emitter. Where emitter is emitting values and the collector is receiving them. So back pressure means that the emitter is sending the value so fast that in simple words, you can say that the collector, like the emitter is emitting values so fast that the collector cannot handle at the same pace. So at that time, you need to uh, like have some sort of a back pressure strategy to handle those things. For example, you can take an example like on Android, you have this, let's say you have an app which draws something on the screen. Let's say if the user like moves the finger so fast that it draws like multiple lines, in that case, uh, probably you won't be able to handle those values at the same pace the user is giving to you. That's when you would that's the concept called as back pressure, and you need to apply some sort of strategies to handle them. And with flow, they are pretty much covered because of coroutines, like the suspended nature of coroutines. But there are like still some ways like you might need to, like in your specific cases, you might need to provide some sort of strategy, but in general it's like for most of the cases you would not need to do anything special.
Our next question, or the rather the next couple of questions, are mostly on can we use flow with this. So first question from Sagar on about using flows is he asks, can we use flows with file IO operations?
Yeah, like so you can. Yeah, I mean, I haven't tried it personally, but I think you can use it. I cannot tell you, what do you mean like file IO, but like for example, writing. I think instead of flow, you would use something as suspend, probably because it's like a one-off operation where you want to just write to the file or something. In that case, probably you would do that. I think even Flow, like even Kotlin provides in its file IO, it provides when you want to read the files, it provides a better concurrency model, like using sequences, which is also much more nicer. But yeah, like if you want to use Flow, I think no, I think there is you can use it, but I haven't like personally tried it out. Yeah, I need to think about it more.
Okay, what about using flows with Firebase real-time databases?
Yes, so you can do that. So I think I don't know how the Firebase API looks like, but let's say I'm assuming it's like a callback based API where where a function is called when a new value is emitted by Firebase, um, something like that. In that case, in those cases, you can like use the callback flow, which I showed for convert in the part where I showed converting legacy to flow. You can use the same callback flow function to convert your like Firebase real-time database callback APIs to flow.
Okay. And last question about using flows with something. Well, Nishan Pardambar asks, can we use flow with live data?
Yes, yeah. So yes, you can do that. So I wanted to keep this topic like specific to like Kotlin itself and not go dive into like Kotlin for like Kotlin coroutines and flow for Android, um, because I wanted to keep it general. But yes, you can. So ideally, let's say so it's your choice. I mean, you can use flow. So let's say you have some sort of an architecture. For example, you have MVVM. So what you would do is like your repositories or your domain logic or your business logic will have flow and will expose the flow types to the upper layers of your code, like the view model. And in the view model, you can convert the flow to live data. There is already a library from the Android team which has this extension function to convert the flow to a live data. Or the other way is like instead of using live data, you can use flow all the way till view model, and then from view model you like unwrap it to activity.
Okay. I think those are the questions that were asked. Akshay, thanks for this talk, and you and Philip both.